Hello, today we will be talking about linear lines. This will be a two-part series as I want to ensure I cover everything, but not all too much at one time. In this video, we will look at how to identify and solve for the slope of a line. Next, we will look at special properties of slopes, including horizontal and vertical slopes, and what that looks like. And then towards the end of the video, we will look at the point slope equation. In part 2, we'll then go into solving equations using that point slope form, and then we'll look at the most utilized equation for a line, which is the slope intersect form. We will start with the basic geometry to form a line. To form a line, you must have a minimum of 2 points. For example, if you have a point P1, which is -4, -4, and you have a point P2, which is 4, 4, looking at that on the graph, we have 1, 2, 3, 4, 1, 2, 3, 4. So that's P1. And then P2 is 1, 2, 3, 4, 2, 3, 4, P2. And because we have 2 points, we can form a line. If you have a line that is not parallel to the y-axis, this is the x-axis and this is the y-axis. So if you have a line that is not parallel to the y-axis, then with these 2 points, you can identify what the slope of the line is. So what is the slope of the line? Well, the slope of the line essentially tells you how steep the line increases or decreases. Slope can be either a negative value or a positive value. Looking at the graph that we have right now, this would be considered a positive slope because it's going in the positive direction, this way. It's also going this way, but the slope is positive. If we wanted to look at a negative slope, essentially it would just be the mirror image of what we have here, and it would go this way, and it would go this way. So that's the negative slope. And if we wanted to do 4, 4, -4, -4, then we would have the point right there, and we would have the point right there. In this case, the point would be, if this was P1 and this was P2, P1 would be equal to -4, 4, and P2 would be equal to 4, -4. Slope in algebra is represented by the letter M. And note that this is a lowercase m. So back to how steep the line is, or the slope. So the slope will tell you how far to go up, whether that's in the positive direction or the negative direction. That is also referred to as the rise, and the slope will tell you how far to go in the x direction, whether that's in the positive direction or the negative direction, and that's considered the run. So you might hear rise over run, and so the rise again is going up and down the y-axis, and the run is going across the x-axis or up and down the x-axis. You are able to find the slope by utilizing any 2 points on the line by taking the change in y over the change in x. Oftentimes, you will see the change in y and the change in x denoted by the Greek letter delta, which represents the change in y, and then you have the change in x. This delta sign, again, just means the change in. And the change in is another way of saying the difference or the subtraction. Using this is equal to our slope, which is also equal to y2 minus y1 over x2 minus x1. Looking at the graph that we have, y2 minus y1 is the change in y, which is how far up or down we're going across the y-axis, and then the change in x is how far we're going across the x-axis. If we're using 2 points that's on a line, then what we're doing is identifying how far away these points are in the y direction, and then how far these points are in the x direction. Your x and your y values come from any 2 points on the line. Using the graph we have here, let's find the slope. If we are using this point right here that we have, P1 and P2, all we need to do is plug in the values because we have 2 points that lie on this line. We want to find the change in y, or the change in the y-axis, divided by the change in the x-axis. Plugging in the points, we have y2, we're coming from P2, which is 4 minus 0.1 is a negative 4, so we do plus 4, because again we have a negative and a negative and a negative equal positive, and then divide that by, and we want the change in x, so we do 4 minus, and then minus another negative, plus 4. Reduces down to 8 over 8, and this is equal to m, and 8 over 8 is equal to 1. Now, we also know that 1 is equal to 1 divided by 1. And the reason why I'm writing this is because this will tell us, right, the change in y, so the rise, and this will tell us the run. With this, we can go, looking at the graph, if we wanted to add more points, so say we're at point 2, and we wanted to find the next point. With the slope, we would go up 1, and then over 1, and that's our next point. Similarly, if we were down here, we can go up 1. If we were at the origin, we can go up 1 over 1, up 1 over 1, up 1 over 1. And as you see, this equals the straight line that we currently have. So this slope is the rise, right? How far up or down you go in the y direction on the y-axis, and then the run, which is this bottom number, how far you go in the x direction. So if you're starting at this point here, right, at P1, and you wanted to find the next point, you would just go up 1, and then you would go over 1. Here, we would go up 1, and then we would go over 1. Up 1, over 1. This slope will tell you, if you have 2 points, what your next points are going to be. If we wanted to do the exact same thing for this graph over here, we know that it's the mirror image, and so the mirror image, just so you guys know, is the negative value of the slope, but we can just plug this into the equation to check. Using our equation for slope, we can do y2, so negative 4, minus 4, because it's P1, which is y1, divided by, and then we do x2, so we do 4, because that's the x value at point 2, and then minus x1, so minus a negative is a positive. So we get negative 4 minus negative 4, which equals negative 8 over 8. And this reduces down to a negative 1 over 1. And so this is the same thing. So say we start at point 1, we're going to go down 1 because it's a negative, right? So we're going to go down 1 and then over 1. And then we're going to go down 1, over 1. And we keep this process going. Go to the origin, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and we can just keep going. Say you wanted the negative in the bottom, or the denominator, versus the numerator. Well, this is the same as saying 1 over negative 1. So what would that tell you? That means you would go up 1, right? This would say you would go up 1, but you would go to the left 1, up 1, to the left 1. So it's the exact same thing. It just depends on preference for you, on if you want to go in the negative direction on the y-axis, or if you want to go in the negative direction on the x-axis. It creates the exact same line because the slope is constant. Okay, let's try one more example. Looking at our example, we have P1, which is 4, -5, and we have P2, which is -3, 6. If we wanted to see this graph, all we would need to do, we go over 4, down 5, and on this one, we go back 3, up 6. And we would, this is P2, and this is P1, and we would connect this line, and we're asked to find the slope. And again, slope is denoted M. So with slope, we get the change in y over the change in x, which is equal to y2 minus y1 over x2 minus x1. I do want to note that if this was just P and this was P and not 0.1 or 0.2, it doesn't matter which one you select as 0.1 or which one you select as 0.2, as long as it stays consistent through the whole problem. But because they've already labeled P1 and P2, we will just use P2 as the y2 and the x2 value. So plugging our points into the equation, we get 6 minus plus 5 over, and then we get -3 minus 4. And this is equal to 11 over -7. And this, of course, can be rewritten as a -11 over 7, which is the same thing, equal to M. And this is our slope. So what does this tell us? This tells us that we have a negative slope, and this is in the negative direction, so that's good. And it says if we want to find our next point, we would need to go down the y-axis 11 marks, and then we would need to go across the x-axis 7 marks. So if we wanted to write this out, we would go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then we would go over 7 points. 1, 2, 3, 4, 5, 6, 7. And we would connect that here, and this would be our next point on the graph. Now if we wanted to go in the other direction, starting at this point over here to the left, then what we could do is go up 11 and to the left 7. And then this would be our point way up here. And then we'd be able to connect that. Okay, now that we understand what the slope of the line is, let's look at a few special cases that's dealing with horizontal and vertical lines. In the graph located here at A, we have a horizontal line, which is horizontal to the x-axis, and then in graph B, we have a vertical line is vertical to the y-axis. So if we look at the horizontal line first, say we have a line that looks like this, and this is at the point 0, 3. A horizontal line is a straight line, so we can choose any point we want. So say we choose a point over here, which is -1, 3. If we try to solve for the slope, we have M equals y2 minus y1 over x2 minus x1. We plug in the numbers. In this case, I want this one to be my P2 value, just because. And so if that's the case, I'm going to do 3 minus 3. So this 3 minus this 3 minus the other 3, and I'm going to divide that by -1 for x2 minus 0. When we simplify, we get 0 over a -1. And we know that 0 divided by any number is equal to 0. And that is our slope. So this is saying that there is no rise at all. That is what this is telling us. That's saying that it's just a flat line. So this is our first special case. If we have a slope m that is equal to 0, then we know that the line is horizontal. Again, because there's no rise, only run. Rise in this case is 0, so that means we're only running, which means we're only going across the x-axis, which is why we see the x values only changing. The y value stays exactly the same because we are not going up or down the y-axis. Looking at another special case, in B, say we're looking at a vertical line. And say we're looking at this point right here, which is -2, 0. And if we want to choose another point, say right here, let's say this is, again, -2 because we're going over to the same point, and now we're coming down, and let's call this -2. So let's say that point's -2, -2. Now, if we try to find slope, so m equals y2 minus y1, and we divide it by x2 minus x1. In this case, let's choose this as P2, this point is P2, so we're going to use this y value as the y2, so we take -2 and we minus 0 from it, and then we divide it by, we take -2 for x, and we minus plus 2. So we minus a -2, which is plus 2. This simplifies to a -2 over 0. Now, we know that any number divided by 0 is undefined. In this case, m is undefined. And this is because any number divided by a 0, again, is equal to undefined. Therefore, we know that any line with a slope of m that is undefined is a vertical line. Now that we understand how to find slope and we understand the special cases of horizontal and vertical lines, let's look at a couple more examples. The question is a two-part question. We have A and B, and the question asks to sketch a line through the point 1, 1 with the slope of 5, 3. And then sketch a line through the same point, so point 1, 1, but a slope of -5 over 3. Okay, so what we know here is we have the point and we have the slope, and what we've seen previously, we're able to sketch a line based off of that. Let's draw our graph, and we have the point, 1, 1. The next piece of information that they give us is that the slope is equal to 5 over 3. And we know that the slope is equal to the change in y over the change in x. And what that tells us is that we need to go in the distance of y, and then after we do that, we need to go in the distance of x. And so let's do that. So this tells us that the rise of the slope is 5. So if we go up 5, now we've satisfied the change in y or the distance over the y-axis, and now we need to account for the distance over the x-axis. And it says that the distance is 3. So we go 1, 2, 3, and that gives us 5 over 3. Up 5 over 3, and that is our new point. And so if we wanted to do that, we would say up 5, we would say 6, and then we would go over 3, which gives us 4, and that's this point, 1, 2, 3, 4, 5, 6. So up 5 over 3, 1, 2, 3, and now that we have 2 points, we can sketch this graph. If we wanted to check another point, we can multiply the top number by a -1, and the bottom number by a -1. And if we do that to 5 over 3, which is our slope, that's going to give us -5 over -3. And the only reason why I'm doing this is because instead of going in this direction, I want to try to find a point that's in this direction. If we multiply the entire number by a negative over a negative, that's really multiplying by 1, and it doesn't change the value. So with this, we're going to go down 5. So this is at 1, 1. So we're going to go 1, 2, 3, 4, 5. And now we're going to go over 3. So this is 1, 1. So 1, 2, 3. And that's going to give us this point right here. And this is going to be, to check our work, we do 1 minus 5, which gives us a negative 4. And then we do 1 minus 3, which gives us a negative 2. And that's this point here. And we see that both this point that we found and this point from the slope does lie on this line. And therefore we know that that is the correct line. And we have satisfied A. Now if we wanted to do B, what we're doing is instead of doing a rise of 5, we're doing a rise of negative 5 if we're still using the point 1, 1. So with that, we're going to go, instead of up 5, we're going to go down 5. So we're going to go 1, 2, 3, 4, 5. However, we're going to go over to the right 3. 1, 2, 3. And that puts the point right there. And now because we have 2 points, we can connect these. And that's our line. Now that we've practiced how to draw a line with the slope and with a point, or with 2 points and finding the slope and then using that to figure out the line, now we want to start looking at how to form an equation given the information that we have. At this point in time, we know that slope m is equal to the change in y over the change in x. We've seen this to be y2 minus y1 over x2 minus x1. For simplistic sake, what I'm going to do is make this point an arbitrary point, and I'm just going to call this y minus y1, and we're going to just call this x minus x1. Again, we can call that y2, or we can call that x2, but we're making it arbitrary, and we're saying any point within that line. That's why I'm switching it to y and x. But we know that this is equal to m. Now, if we wanted to move this x quantity all the way to the right side, that would leave us with y minus y1 equals mx minus x1. And again, all we did was move the x variables over to the right side. If we were to write the slope in this form, this is known as the point slope form. Depending on the class or the teacher, they may ask for this form. But because you understand how to solve for slope, you'll always be able to create this equation. Just know that if it's written in this form, it is called the point slope form for the equation of a line. If you forget how to create this, just remember we're using the equation for slope, which is the change in y over the change of x, and then all we're doing is moving x to the side with m on it. And rather than using P1 and P2, you're using 0.1 and an arbitrary point, because that could be 0.3, 0.4, 0.5, it doesn't matter. We're making it arbitrary, and you're just making it any point that's on the line. When you select a point, you would just need to plug it into that equation. And with this, you will find an equation of a line written in point slope form. In part 2, we will go over the detail of the point slope form for the equation of a line, and we will also go over the slope intercept form. We will also do a couple of equations using both of these so that you guys can understand how to apply these principles. And so with that, if you have any questions, please leave them in the comments below. If you learned something, please like and subscribe, and we'll see you in the next video.